Welcome back, folks. More seat of the pants circuit analysis. This one I'm going to introduce. We talked about this component when I was talking about voltages and currents and the schematic symbols. We haven't done any analysis with them, so I want to ease you into that, and I want to do a little bit of reinforcement of using some of the other fundamental laws. So it's not a big problem. That's okay. But it has a new component, so that can throw people a little bit. I want to introduce this early so that you're not scared of it, because there's no reason to. All right, so here it is. Check it out. Okay, we want to find IX, which got cut off here. So let's just write it up here in the margin. Find IX. I want to find this current here. And the new component that we haven't really touched, but I did introduce earlier, is the dependent current supply over here. It's got the diamond around it, is the first giveaway. The other giveaway is that its value is dependent on some other value in the circuit. So 3 times IX is flowing through this current supply, and this is IX over here. So we call this the control variable or the dependent variable, and we have to look for that somewhere else in the schematic. And there it is. Check it out. So we can use that. Okay, we're trying to find a current. So let me kind of go down my laundry list of what methods I have that we could use to find that current. We can use Ohm's law. Well, Ohm's law does involve a current, but we'd have to know a resistance. And if you look at this problem, the resistance isn't given up there. It's just not listed. There's some resistance that makes this all work, but there's no resistance given in the problem. So Ohm's law seems like it won't work. I'm looking for a current. So I'm probably not going to use KVL, because KVL, everything has to be a voltage. There's only one voltage in this circuit. That's it. Okay, so if I want a current, that kind of leaves me with KCL. And I think I can make KCL work in this case. I'm going to pick a node, top or bottom. I'm going to end up doing both. So let's start with the top. I want to emphasize that it doesn't matter what you pick. Just pick a node and go with it. Okay, so let's call this top node, which extends all the way around here. Okay, but I'm going to draw that dot there to indicate that's where the blue node is. Has 3 components connected to it, and 4 mils is going in. Okay, IX is leaving through there, and then over here I've also got 3 times IX leaving because of that dependent current supply. Those are all 3 components connected to the node, so that's equal to 0. All I have to do is solve. Look, I've only got one unknown, and I've got one equation. So I can, let's move those over. Negative or positive IX and positive 3 IX. Okay, now I can pull IX out of there, and I can say that I have 4 mils and 4 times IX. All right, finally IX is equal to 4 mils over 4, and that's the gain from the dependent supply. Okay, so there we go. Using the top node, I can find IX in that way. And oh, I didn't actually it's 1 mil, right? You did that in your head. Equals 1 milliamp. Okay. So let's play that game again, and let's play that game with the bottom node, and you're going to get to the same result. Pick a node, go with it. It doesn't matter. Okay, so from the green node, 4 mils is leaving. IX is entering, and plus 3 IX is also entering, and that's 0. So let's bring the 4 mils over this time, and I get IX plus 3 IX equals 4 mils. Hey, isn't that what I had over here? Pretty much over here? Yep, just flip the sides. Okay, so it ends up being equivalent, and we get 4 IX equals 4 mils, or IX equals 4 mils divided by 4, also known as 1 milliamp. All right, same answer. Didn't matter which node I picked. We get to the same place. I could tell you one is right and you should always pick the top node. I'd be lying. Okay, there's a lot of things that are up to your discretion in circuit analysis. Some of that will go away as we get a little more procedural in how we approach this, but there's more than one way to get to the right answer. As long as you're going the right way, I don't care. I'm not coming with you to your job. You have to pick the way that you're confident that you'll get the right answer in the end. Okay? So I think we're going to do maybe one, maybe two more examples. I'm still trying to decide on that one. Oh, you couldn't see that. There it is. Right there. Sorry about that. My big head was in the way. We're going to do one or two more examples of this, but then we're going to dig into our first kind of structured method of analysis. It's the part of the class that I truly enjoy because I can teach you how to analyze any circuit. And that's a skill that's actually useful in your future classes, in your careers. And I think the structured way of thinking is also good, just as an engineer in general. Okay? So, stay tuned and good luck.